Gluconeogenesis. So today the topic for discussion is gluconeogenesis. Gluconeogenesis is the process by which glucose is produced from non-carbohydrate sources. The site it occurs mainly in liver and to a lesser extent in renal cortex, pathways partly mitochondrial and partly cytoplasmic. The reactions of gluconeogenesis, main reactions when we are talking about the substrate pyruvate is there are three reactions: pyruvate to phosphoenol pyruvate, fructose 1,6 bisphosphate to fructose 6-phosphate, and glucose 6-phosphate to free glucose. Key gluconeogenic enzymes for these steps are pyruvate carboxylase, phosphoenol pyruvate carboxykinase, fructose 1,6 bisphosphatase, and glucose 6-phosphatase. So the irreversible steps which are taking place with the help of pyruvate kinase, fructose phosphofructokinase 1, hexokinase. These irreversible steps of glycolysis are made possible with the help of the enzymes of gluconeogenic new enzymes, that is pyruvate carboxylase, phosphoenol pyruvate carboxykinase, fructose 1,6 bisphosphatase, and glucose 6-phosphatase. So the first step when we are talking, when it is the starting is pyruvate, this pyruvate is in the cytosol. This has to enter the mitochondria. So this enters the mitochondria, and this when it enters the mitochondria. So now you can see that this is the cytosolic pyruvate which enters the mitochondria. Inside mitochondria it is acted upon with pyruvate carboxylase to form oxaloacetate. This oxaloacetate is reacted upon with the malate dehydrogenase which forms malate, and this with help of malate is shuttle shifted to cytosol. In cytosolic malate dehydrogenase acts upon malate to form oxaloacetate, and oxaloacetate forms phosphoenol pyruvate with the help of the enzyme phosphoenol pyruvate carboxykinase. Now once we get this phosphoenol pyruvate, this phosphoenol pyruvate will form fructose 1,6 bisphosphate. So now you can see this phosphoenol pyruvate is forming fructose 1,6 bisphosphate. This is just like a reversal of glycolysis. So okay, 2-phosphoglycerate, 3-phosphoglycerate, 1,3-bisphosphoglycerate plus protein 3-phosphate plus dihydroxyacetone phosphate, and this combines to form fructose 1,6 bisphosphate. This fructose 1,6 bisphosphate will now form fructose 6-phosphate, and this happens with the enzyme fructose 1,6 bisphosphatase, because fructose 6-phosphate to fructose 1,6 bisphosphatase is a irreversible step of glycolysis. Next, there is an isomerization, so fructose 6-phosphate will isomerize to form glucose 6-phosphate. Then from here, another phosphate is removed, so it forms glucose 6-phosphatase is the enzyme to form glucose from glucose 6-phosphate. This is from primary glucose cells. Now there are many other substances which can gluconeogenesis. The other substances are lactate. Another one is glycerol, glucogenic amino acids, and long-chain fatty acids, forming propionic way to enter process. So your fructose 6-phosphate also forms fructose 2,6-bisphosphate through phosphate kinase 2. So glycerol forms dihydroxyacetone phosphate. They form glycerol 3-phosphate. So this is a phosphorylation of glycerol. We form glycerol 3-phosphate, and glycerol 3-phosphate forms dihydroxyacetone phosphate with the help of the enzyme glycerol 3-phosphate dehydrogenase. Next, lactate forms pyruvate through lactate dehydrogenase. And your odd chain fatty acids enters the cycle to succinyl-CoA, that is short chain fatty acid will form propionyl-CoA, and this will form succinyl-CoA in multiple steps. Then there are many glucogenic amino acids entry, which is represent these numbers, that is 1, 2, 3, 4, and 5. So at first, there are alanine, glycine, serine, cysteine, and tryptophan, which enters. Aspartate and asparagine will form oxaloacetate. Glutamine, glutamine, arginine, histidine, and proline. This forms alpha-ketoglutarate. Valine, isoleucine, threonine, and methionine. This forms succinyl-CoA, whereas your phenyl and thyroxine, this forms fumarate. So this is overall representation of gluconeogenesis.